popular tools. The Tesla AutoPilot feature in their cars, this was built using PyTorch. Stable Diffusion, one of the most popular image generators, this was built using PyTorch. And Llama 3, is that me? Oh. There we go. And Llama 3, right? Grant mentioned that today, I think the biggest LLM that's ever been created was released today. And that was built as well using PyTorch. And of these products, we do have a demo of Stable Diffusion that Alex is going to be given. And we also have a Llama 2 demo that Patrick put together. This demo is going to show you how you can run this model on your own computer. That's at the end. And I'm going to share these slides also at the end on the Telegram group, so don't feel afraid of losing any information. And of course, we can speak afterwards, right? And I have links sprinkled in all over, right? So you can see I'm not lying, right? This is the former director of AI at Tesla. This guy is pretty popular in the machine learning community. His name's Andrei Karpathy. He's a big PyTorch fan. And it's lagging a little bit, but yeah. All right, cool. All right. All right, here we go. Has anybody seen this chart before? Okay, so this is a website called Papers with Code. They track all of the research papers that are done by ML engineers across a variety of outlets. And they're tracking what machine learning framework is being used to flesh out these research ideas, right? Research is where all the cutting edge stuff in AI is being done, right? It's not people like me or just playing around in our backyard. It's people who are doing it at a high level. And you can see here, this chart is showcasing, right, on each month, the percentage of the research papers that are implemented with different frameworks. And you can see here, the overwhelming majority, right, the overwhelming favorite is PyTorch. So what you're learning here today is very applicable. It's used all over. Many products, like the leading products in AI, are built with this tool. And another thing too is, in this world, you're going to see the term ML a lot more than AI. That's why I put that up at the top. So AI is kind of like a buzzword, means a lot of different things depending on the context. PyTorch is a tool that allows you to do machine learning at a large scale. That's the term that the people who built this tool will use or would use to describe the domain that they work in. Machine learning. Here's a history of PyTorch. So it was originally called LuaTorch. It actually dates back to the 2000s. It was maintained by one guy for about 10 years. And in 2016, one of the members of the LuaTorch community, at its peak, LuaTorch only had about 140 developers. It was an open source project as well. But one of the members of the LuaTorch community reached out to another member of the LuaTorch community who was working at Facebook. And this first guy, his name was Adam Pashka. So he reached out to Sumit Chintala. Sumit Chintala was the director of AI at Facebook at the time, or one of the directors of AI at Facebook. Adam Pashka was a freshman at the University of Warsaw. He reached out to the director of AI at Facebook for a summer internship, and they decided on a project where they were going to rewrite LuaTorch in Python. Lua is a programming language that was created in Brazil, sort of obscure, And they thought that if they rewrote it in Python, it would make this library a little bit more accessible. And it turned out that they were right. Shortly after making this decision and rewriting some of the modules, the LuaTorch community moved completely over to the PyTorch version of the library, and the LuaTorch code base became discontinued. And then in 2019, yeah, it was, I guess, deprecated or completely discontinued. It hasn't had any code push since 2019. And yeah, PyTorch has seen amazing growth since then. It's a tool for doing machine learning. Some of the products, as I mentioned at the beginning, that have been built with this have been ChatGPT, Stable Diffusion, Tesla's AutoPilot, and yeah, billions of people around the world have been impacted by this tool. It's, you know, under the hood of many of the tools that you probably already are using. Here's an overview of the main contributors that built this tool, PyTorch. And you can see here the different companies that they work at now. Right? So, right? Heavy hitters, I would say, people at the top of big tech, right, came out of this community.
Completely different.
I tried to make like a meme. I guess that didn't work. But yeah, you know, Monty Python, and now for something completely different, right? All right, so now we're moving out of part 1. We're going to part 2. This is the history of PyTorch. Second trivia question. Second trivia question. Who is this? Yeah, he's fast. So what do you want? Some coconut chocolate, licorice, coconut chocolate. All right. I hope the feedback doesn't happen every time because I have some audio, but we'll see. Here is the history of NVIDIA. So NVIDIA was founded in 1993. Their original vision had nothing to do with AI or machine learning. Their original pitch was that they were going to make chips for the emerging high-performance gaming industry. So in the early 90s, people started wanting to make and play more intensive video games. The computers at the time couldn't handle some of the things that people wanted to do. It required more advanced hardware, and that was the need or the demand of the market that NVIDIA saw, and they ended up being correct in a number of ways about this thesis. A year after they founded the company, they raised $20 million. The next 3 years after they raised their first seed round, or they raised their first round, they were losing money. And then after 3 or 4 years, they finally made a chip that had some commercial success that they, broke even with for that month. And then it was 5 years after they released their first chip that they had their, I guess you could say their first blockbuster. They released a chip that was branded as their first G-Force chip. I don't know if anybody here has bought one or interacted with this. It's used for gaming. So if you're somebody who's ever played Halo, have you heard of this game? Anybody heard of Halo?
Yes.
Yeah? Yeah. As a kid? Yeah, Halo was amazing. I mean, it was very popular. I've never been a gamer, but I'm aware of games myself. Like, I'm aware of Halo, right? There's other games like Fortnite. I've never played any of these games, but I'm aware that they're, big things. Roblox, blah, 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 right? All right, cool. So after they released this blockbuster of a chip, I guess this is good for context. This is the type of graphics that were, cutting edge at the time. Like I said, I have some cool links. But yeah, that's the type of, graphics that NVIDIA was enabling at the time, like, plasma guns and stuff like this. It was really cool at the time, right? All right. A year after they released that GeForce chip, they won a $200 million contract from Microsoft. And NVIDIA was the chip designer, and they also did the delivery and manufacturing, I think, for the Xbox. So the graphics chip that was behind Halo, all those games, that was enabled by NVIDIA. 2 years after Halo came out, NVIDIA was one of the biggest 500 companies in the US. They entered the S&P 500. In 2004, they won the contract to design the graphics chip for the PS3. In 2007, they released a programming language. That's how I think of it. I've actually never played around with it. Maybe you can shed some light on this. They released a programming language called CUDA. This allows third parties to program their chips. NVIDIA makes chips. People want to make cool applications on top of their chips. You're going to have to write in a language called CUDA if you want to leverage their chips. PyTorch leverages CUDA for training huge AI systems. That's how, PyTorch is connected to NVIDIA. From 2007 to 2016, NVIDIA made about $4 billion in revenue per year. In 2017, NVIDIA won some huge contracts to supply Google and Baidu with chips powering numerous of their cloud products. In 2019, that's when NVIDIA started to have this inflection, and it was driven most notably by the AI boom that we're still in. Everybody here, was here partly because of this AI boom. And last year they had their biggest year yet. They pulled in, $61 billion in revenue. And now, in terms of this metric called market capitalization, NVIDIA is actually considered the third most valuable company in the world. So I thought this was an interesting story. They had no idea that they would be in this position, right? They started making video games, right?
There's another step in there, the big wave of crypto. All of the millions and millions of chips that were in huge demand.
Yep, within 2019.
Yes, that drove this company another unexpected use, but the electricity that was being used, shutting down local electric grids, would have been all due to NVIDIA chips solving crypto puzzles to make Bitcoin.
So here I wrote, NVIDIA accidentally finds itself in the position of enjoying demand from several simultaneous tech waves, most notably the AI boom. But yes, that's what I meant by that.
I understand.
Yeah. Great point. Yeah. If anybody has any input, right? I don't want you guys to be boring and not alive, right? Please interact, right? Come alive. All right. Next trivia question. Let's go. Which company below has a higher market cap than NVIDIA? Is it Walmart? Is it Saudi Aramco Oil? Yeah, there we go. All right, cool. Gotta own it. So we got ginger, milk chocolate, licorice, Australian licorice. Okay. Yep, it is Saudi oil, right? I didn't realize how rich Saudis are. So last year, I guess the 12 months ending Q1 2024, like I said, these numbers are probably approximate, but in the past 12 months, NVIDIA has pulled in $80 billion revenue. They're making really good profit. Maybe that's why their market cap is so high, but they currently have a $2.3 trillion market cap. And yeah, I think that's interesting to note against these other companies, right? So they're making only 80 billion, right, per year. Saudi Aramco is making 603 billion, right? And Amazon's making 590 billion, right? But currently, I guess they're projected that they're going to grow even more, right? Their profits are good, but you can see Berkshire Hathaway has great profit too, right? Warren Buffett. And they have a market cap that's like more than double Berkshire Hathaway. So anyways, interesting to note. I know it's not so simple to analyze this stuff, but I just thought it was interesting. Yeah, I think the median salary at NVIDIA is somewhere between 250 and 300,000. So if you hear of somebody who works at NVIDIA, there's like, I guess, about a 50% chance that they're pulling in at least 250K a year, maybe more. That's how much revenue the business brings in per employee, right? NVIDIA has about 30,000 employees. And here you can see the growth of their revenue, right? So about 2020, as Stephen was mentioning, right? That's when they had their inflection. And then I think they're going to be even higher, next year. I think they're going to be moving up into like maybe one of the biggest 40 companies by like more metrics than just market cap. I think they're on track to maybe hit like 100 billion revenue this year, maybe 120 billion. Last year they were number 61 as far as the largest companies making revenue. But yeah, market cap, they're currently valued as the third most valuable company. Trivia question. Which company competes directly with NVIDIA? All right. A cookie. Swedish fish. You want a cookie? This one? All right. Next trivia question. Turn it off. Oh, we're good. Next trivia question. Who is this?
His cousin. His cousin.
Is it? That's his actual cousin?
That's his actual cousin.
All right. Well, you want to cook? I didn't know that. You see, I learned something. What's her name?
I don't know. Give it somebody else.
No. Nobody knows who this is?
That's it. That's AMD CEO.
Yeah. What's her name?
I don't know, but it's a cousin of
That was you? That was you? Who was that? Lisa Sue? That was you? Who was that? Was this you?
No, that guy said it first.
Who?
Someone over there said it first.
You want? Oh, you already got? You already got one?
I'll take it.
You take it? Yeah.
Here we
There we go. I guess this is not working. Okay.
Sorry, ran out of battery.
Oh, no problem.
This one, see if this one works.
No problem.
Testing. Here we go.
Nice. Do you guys like the mic or without a mic? You like the mic? All right, cool. All right, so why did I show this photo of this woman, right? So, right, yeah. This is the CEO of AMD. Here is a overview of NVIDIA's direct competitors. And AMD is, up there. But they have tailwinds unlike these ones, right? So NVIDIA is like dominating their sector. I mean, it got shut down about 2 years ago. NVIDIA was actually trying to acquire ARM, and a bunch of regulators and a bunch of countries stepped in. They didn't want one country, one company, one CEO to have so much power over the chip industry. But yeah, you can see, I think by next year, NVIDIA is going to be like over 50% of the chip market. But yeah, I thought this was interesting. Here's the history of NVIDIA and PyTorch. So in 2005, this is, according to my research, when people first started experimenting with leveraging their chips for machine learning. In 2007, that's when NVIDIA released their proprietary programming language. This is what allowed third parties to write custom programs on their chips. And I guess an interesting thing to note about CUDA is my understanding is it is open source, but it's proprietary. So they don't let other companies leverage it in certain ways so that they maintain a competitive advantage. But it is an open source programming language from what I understand. In 2009, that's when there started to be some large scale studies of using their chips for doing different types of deep learning. This is just a branded form of machine learning done at a huge scale. What we're talking about today is all related to machine learning, but when it's done at a huge scale with lots and lots of data, with huge computers, huge networks, it's branded as deep learning. In 2010, that's when you start seeing the use of GPUs for machine learning spread around Europe. We were talking about LuaTorch, right? This is the predecessor of PyTorch. This library integrated with CUDA and NVIDIA GPUs in 2011. In 2012, this is a pretty momentous thing in AI. This was a competition that Google had put on for years, where they were crowdsourcing engineers to build a system that would allow them to automatically label images that come online. And it was built by Alex Comerford and Ilya Sutskever. Ilya Sutskever is one of the founders of OpenAI. So I think this is what made Ilya Sutskever a millionaire. And yeah, he built this system that was able to automatically label images, right? You show an image of a dog, the AI can understand that they're looking at a dog, an image of people laughing around, a kitchen. It's able to tag it with all these meta tags, blah, 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 right? Ilya Sutskever and the people he built that system with sold that to Google, I think, for like $40 million. Anyways, in 2015, that's when OpenAI was founded. And then in 2016, Jensen hand-delivered, I should say, I think I want to look at this one. Jensen Huang hand-delivered the latest NVIDIA GPU model to Elon Musk and the OpenAI team, right? In 2016, the latest model was the DGX-1. And yeah, this is a tool or a piece of hardware that allows a company like OpenAI to build systems that are going to be, multiples bigger than competitors, and allow them to build it, in a fraction of the time that a competitor would, take to build a similar scale system. In 2016, that's when this character by the name of Adam Pashka reached out to the director of AI at Facebook, and that's when they started converting LuaTorch, which was written in a programming language called Lua, into Python. In 2020, OpenAI announced, they had a blog where they announced that they're only going to be using PyTorch for all of the development they do for all of their models. Right? So another headwind for PyTorch. And here, this is the paper that OpenAI published where they shared all the details of how they built GPT-3. After the release of GPT-3, they started being a little bit more private with the sauce. But here they say that they used NVIDIA GPUs for training GPT-3. And here is the last image I have on this timeline. This was taken earlier this year, and I showed an image before of Jensen Huang hand delivering the latest NVIDIA chip to OpenAI, and the same thing happened earlier this year. So the latest NVIDIA GPU model has this name. It's DGX-H200. And yeah, this is going to allow OpenAI to, continue to make models faster than competitors, at a scale that, people aren't going to be able to compete with, people who don't have access to this level of hardware. And yeah, that's the history of NVIDIA and PyTorch. I probably should speed things up. I'm going to move a lot faster. All right. All right. So what does PyTorch have to do with NVIDIA? A, B, or C? Who said that? Was you? You want dark chocolate, gummy bears? Gummy bears. All right. Yeah, this is a meme. I won't play the audio, but if you can't run, if you can't fly, run. If you can't run, walk. If you can't walk, crawl. But by all means, keep moving. So for me, this is just start where you're at and then build up to, build it from there. This is where we're at today. This is where I'm at with my understanding of this stuff. There's levels to this, but we are where we are. We're just going to keep moving, right? All right, cool. So this is often how you'll see AI presented or taught, right? There's this notion of narrow AI, broad AI, super intelligence. And we're going to be playing today in level 1/level 2 area, right? But yeah, now you're seeing a 405 billion parameter model that was released today, for example. And yeah, you can see the trend that these things are just going to get bigger and bigger, and just more compute is getting funneled into them. That's the clear trend that's happening. And that seems to me to be the brute force way everybody's trying to achieve this thing called super intelligence, which is the goal of making this system that can do anything, right? Instead of having these, specialized systems. In physics, you hear this concept of like the grand unified theory, right? So instead of having like different, I guess you could say, specialities or different domains within physics, they're trying to create like a understanding of the world that allows everything to be explained. And the same thing with AI, right? Instead of having these systems that are specialized in doing one specific thing, like one thing for, being able to transcribe audio, one thing for being able to diagnose diseases, one thing for being able to, to write copy, right? One thing for image generation. That's the goal of OpenAI. They're trying to make this system that's capable of doing everything, right? That's super intelligence. One way of explaining it. All right, here we go to the fundamentals. I'm going to move fast. So who is this? All right, we got toffee, almond, sea salt, and oh shit, fuck, yeah. We got ginger can. You want chocolate? Here. Yeah. Yeah, then I was describing on the previous slide, right? So Andrew Ng, right? So he's an OG in this space, right? So, I mean, only a couple of years after people started experimenting with GPUs, he was doing like large scale studies on this stuff. And yeah, he's worked at Google, he's worked at Baidu. So anyways, a lot of the visualizations that I'm about to show you come directly from him. So yeah, anyways. All right, so now we're in the fundamental section. We're moving into part 3, and then part 4 is going to be the demos. Get ready. Right, so this fundamental section is going to be in 5 parts. We're going to cover these concepts. So we're going to discuss the difference from a very high level and very quick manner, the difference between biological and artificial neurons. Then we're going to show how machine learning is actually quite simple. When I first started learning about this stuff about a year or 2 ago, I thought it would be more complicated, but it's actually quite simple, like how it really works. I mean, my current understanding, obviously there's levels to this, right? Then when I talk about cost and loss functions, then multi-layer perceptrons, then this is, from my understanding, from everything I've seen, this is like the driving algorithm that powers a lot of this learning. That these systems, like the capabilities that these systems are able to do is powered by this algorithm called backpropagation. Then we're doing some demos, right? All right, so let me move fast. Okay, so yeah, this, it was playing with feedback. This video is really cool. But yeah, on the left here, we have, a diagram of a brain cell. And then below, we have what you'll often see in like these, you ever see these like networks or diagrams, you ever see these diagrams of neural networks where it's like a bunch of dots and you see a bunch of lines connected to everything, right? And you're like, what the fuck is this? Blah, blah, blah. And then these circles, right? This would be like one of the circles, right? And usually you see these diagrams, right, of neural networks. Probably could pull one up. I think everybody knows what I'm talking about, but excuse me for cursing, by the way. Yeah, these diagrams, right? People know what I'm talking about? Yeah, so this is roughly one aspect of what they're trying to do with this is they're trying to simulate like a network of brain cells. And each of these nodes represents one brain cell, which is also called a neuron. Like I said, anybody knows about this stuff, please raise your hand or just shout out and jump in. But yeah, this is what neurons in your brain look like under a microscope. But this was cool. All right, and this video is really cool too, but I hope the feedback doesn't see.
Since we've examined
Yeah, what the feedback? Yeah, I guess it doesn't need to, yeah. But yeah, this is a visualization of a brain cell, or like, you know, a network of brain cells in your brain. And most of your brain cells have an input and an output, right? So the output is called an axon. The input for each brain cell is called a dendrite. So what we're going to show on the next slide is how you can, you know, roughly mimic this with an artificial neuron, which is nothing more than a very simple math equation. So yeah. All right, cool. All right, next trivia question. How is a neuron implemented in, yeah, there we go. That's cool. I like that. I like that you jumped in fast. What was that? Oh, are you again? Okay, yeah. You're alive. You're alive, sir. I respect you. You're alive. I'll give you some mints, all right? The right hand.
We're gonna have to buy him dinner by the end of this.
Yeah, it's all good. Yeah, then also I'll say whoever answers the most questions, you're gonna get an extra prize at the end. All right? All right, cool. All right. So, like I said, I've been throwing myself into this area of study, you know, in a pretty immersive manner over the past month or two. I'm sharing my current knowledge, but like I said, that goes back to that meme. You can't fly, run if you can't run, walk, if you can't walk, crawl. This is my current understanding, but from what I'm seeing, the way that artificial neurons or neurons are implemented in, you know, these neural networks, it's usually by combining two very simple math equations. One of these equations is for simulating the input side of the neuron, right? Or the dendrite. This is where the signal comes in. And then you have one other math equation that simulates the output of the neuron. You know, in neurology, or I guess neuroscience, that would be called an axon. Yeah. And you can actually, from my understanding, you can simulate the input side of the neuron with pretty much any math equation, right? I don't know if you remember learning this stuff in high school or middle school. You're like, wow, this stuff is so pointless. It's not related to anything. And then here I am learning AI. I'm like, wow, this is literally everything that AI is. Like, it's literally exactly the stuff that I was, right? So it's like, you know, ML, AI, it's like applied mathematics, right? It's very directly related to this stuff. That's what I'm seeing. But these are some of the, you know, very common, popular, basic equations that you learned in high school, right? And this is literally, right? You're not going to see the connection right away, but hopefully in the next few slides, it's going to be like, right? And you're like, okay, this is literally a neuron, right? A neuron in my brain, or it simulates a neuron in my brain. So yeah, you can use almost any equation to simulate the input of the neuron, right? The dendrite. The output of the neuron, right? From what I'm seeing, it can be modeled with not as many equations, but these are some of the ones that are used to model the output side of the neuron, right? And I don't expect you to like grasp this stuff or to be like, but like just from a high level, what I'm, I guess, trying to give you is that you can model a neuron in your brain with a very simple math equation, like literally this one, mx plus b, right? This can represent the input of a brain cell in your brain, right? It can pretty much do the same, it pretty much acts the same way in some manner, right? Your brain is obviously doing, like, there's always a caveat that you hear people in AI saying, because there's a lot of aspects of your brain that people don't know at all what's going on, right? But this is what is currently used in all of the AI systems that people are using for a lot of products to emulate the input side of, you know, a neuron. And a formula like this is the most popular one, ReLU. This is the most popular formula or math equation that I'm seeing that people use for modeling the output side of the neuron. All right? And it's crazy, right? You're like, what? I don't know if this is the impression that you guys have, like, what is this? This means nothing, right? You combine this, right? You combine this equation with one of these equations, and then you chain them together a billion times, and then you get Llama 3. You get, right? Am I right? You get Tesla Autopilot. You get, Whisper, right? Like, it's this simple thing just done in repetition, billion, trillion times over and over again. Yeah. So that's the takeaway, right? So putting everything together, this is what an artificial neuron looks like. So f of x, this is representing the input side of the neuron. The input receives data. That's x, right? Depending on the model that you're training, x is going to represent a different thing, right? It can be sensory input. It depends on what you're training the model to do. The neuron will receive some input, some data, right? It's going to do a couple calculations on that data. Sometimes it's extremely simple. After the input has processed the data, it then gets passed to the output of the neuron, right? This is another function. You could have named this both f of x and f of x just to differentiate them, fg, blah, blah, right? Anyways, the input gets fed to the output, and then you have some sort of resulting, output from the neuron. The input gets processed, it gets passed to a function that then passes it out. Then you have, your output of your neuron. So yeah, very simple. Hopefully that's how you guys are feeling. Okay, so next trivia question. Remember this, right? These two slides. All right, so here I'm showing 3 simple formulas that you could use to represent the input side of a neuron. And then here are 3 relatively simple formulas for representing the output of an artificial neuron. If we choose a linear function for modeling the input and a logistic function for modeling the output, then what would the equation of our artificial neuron look like? Would it be A, B, C, or D? Yeah, who said that? You again? Well, you know all this stuff. You said it too? Oh, yeah. Okay. Okay, well, it's getting weird with some of these snacks. All right. We have, it looks like gummy bears, toffee again. There we go. Yeah. All right. Why did this stop going full screen? All right, cool. All right, so I gotta move fast, right? Move it a little too slow. Excuse me for that. All right, cool. So yeah, here we go. All right. So what is this? 8 lines of code. Right? This is a neuron. Yeah, of course. Right? In our neuron, like with the previous example, we're simulating it with a linear function. Everybody remembers mx plus b, right? mx plus b. M, we're going to call that our weight. X, that's going to be our data. B, I guess, luckily, it lines up. It's going to be our bias, right? And then we're going to pass that. The data is going to be processed, right? It's going to be multiplied by a number. Then there's going to be some amount of, value added to it. That's going to be the processing of our input. Then it gets passed out of the neuron. It gets, they sometimes will call the output function the activation function, right? And this is an example of a popular algorithm that you'll see commonly used for this, TANH, right? So here. Here we go. There we go. Okay, so this is what to focus on right here, right? So if I were going to simulate what we're doing right here, right? So it's like imagine somebody was touching me. The way it's pause. If someone was, hitting me on the chest, and then that's the input, right? Like I said, from a high-level abstract manner, it's just input. Something happens, output. Input, something happens, output. So just pretend I'm a neuron, right? So the input is someone hits me, right? And they can hit me in a certain amount of strength, right? It can be really hard or like really soft, right? And then the output is I'm going to say like some sound, right? So if someone hits me, right? This, you can build everything up from this as far as all these advanced AI systems. Like that's the fundamental building block that leads up to a ChatGPT or a Tesla AutoPilot or whatever advanced machine learning system you can think of. That's the fundamental process. When you do that in repetition and with slight variations, that can build up into a neural network and like eventually these products that we're all here, I guess, we were intrigued by. That's what brought us here, right? So the next slide that I have is, right, yeah, then the trigger happiness. Yeah, I think I'll show this slide first. Okay, it's like, what can we do with a neuron, right? It's so simple, right? It's like, all I can do is, It turns out I can do everything with that, right? So, yeah, it turns out we can do a lot. So, for example, we can train it, right? And let me give you an example of what that looks like. So, yeah, then also this tool that I'm using here is called Colab. It's a free tool. You can play around with machine learning. And then also, I guess I'll just give a quick note. This is the drop down where you can interact or run your code on NVIDIA GPUs, right? So the stuff we're doing now is just fundamental stuff. When we go to the demos that Alex is going to be giving, he'll use some of these NVIDIA GPUs, etc. So, all right, so we're going to train this neuron, right? So here's the input, right? 0.1. So this is like me being hit, like let's say it's like this level of strength, right? Let's say that what we want is for the neuron to trigger or fire. So in this example would be me like making some sort of sound, But let's say that we want the neuron to be triggered, but it's not getting triggered, right? So it's like, okay, so that's a problem. I want it to be triggering, but it's not. So what I need to do is make the neuron more trigger happy, right? So the way that I do that is I adjust the weights, right? So I'm just going to play around with this, right? And then you can see the output is starting to change. I don't know if that's too small, a little bit bigger. And yeah, I guess this is probably a little bit boring, but like I guess in a slide or two, you'll see it's like this at infinitum in repetition. You can see the output is changing, right? Right? And we're going to bring it up above 0.5 because the way TANH works is once you have an output value above 0.5, it signals to the neuron down chain that it's triggering. That's the way this works. So we're adjusting our weights, right? We're doing it manually. This algorithm of manually adjusting your weights, it's called random perturbation. This algorithm is called random perturbation. There you can see we've adjusted the weights. We're now above our threshold of 0.5. That means that our neuron, right? This was the input I was receiving. I wasn't saying anything. Now, right? We have trained the neuron. Hopefully that makes sense. This is the mechanism that is happening, in ChatGPT, in Tesla AutoPilot. This is the fundamental mechanism that makes it, you do this billions and trillions of times over, and eventually you have a system that, is one of these products. Yeah, go ahead.
Question.
Yeah.
One, could you also modify the bias to get to
Yeah.
calculation?
Yeah. So the input, right, represents real world data. The real world data is fixed. Unless you want to have a false, I guess now we're getting a little abstract. I guess it depends on how much you guys like math or thinking about this stuff. But yeah, the weights are like, this is like a system where you have knobs, right? You don't want to change the data because you're trying to, work your system to fit or adjust to the data. But yeah, anyways, you can adjust the weight. Anyways, when you stack a bunch of these neurons together, you have what are called like matrices, and you have the weight becomes weights, right? And then biases, right? So you can adjust the weights and you can adjust the biases, you can tune them, and that is what is going to determine the output, right? So you have some sort of input that you're feeding into your system. With me, it's like this, in the example of what we're looking at right now. That's right, I'm getting hit. That's the input to the system. The output,
It would be pretty much like, because you get the input and you get the output in reality, right? And then you're trying to figure out like, oh, I have the ability to hit, and I want you to make that noise, right? And then trying to figure out the weight and the bias would be like, what can I do to make Tab make that noise? And I try to, poke him, yell at him, and then I realize, okay, I can hit. If I hit him, he'll make that noise. And then my iterations and trying to figure out how can I make him make that noise is the iterations that the GPUs are being used to try to generate these values. And then the trained model would be me figuring out that 99% of the times that I hit him, he makes a noise. That would be a trained model, but you don't really determine the weight or the bias deterministically like you would on math on a formula. You got to iterate your way through trying to figure those things out. And that's what you do with PyTorch, right?
Yeah, exactly. So you see how I was randomly choosing these numbers? PyTorch will just automatically do that shit for you. That's what PyTorch does. And do you have something? No.
So it's kind of like you do it over and over again, strengthening the brain.
Yeah. No, 100%. I mean, yeah. Hopefully, I saw Grant was saying something. Try to speed it up, or like, you want to move on to the demos, or like the demos? Yeah, let's do the demos. Yeah, for sure. Yeah. So just to echo what you were saying really quick. Yeah, you always got to adapt, right? So, and like I said, if there's something that you guys want to talk about after, like, I have a bunch of material. I'm going to publish these slides afterwards, and we can expand on these things, if you're interested later. But yeah, good point. I'm going a little bit too slow, I think. All right, cool. So I just wanted to show this slide to echo what you were saying. Does anybody know this guy? Where's the feedback on this is crazy. But yeah, he's saying, learning is just repeating something over and over again. If you want to make money, you just do something over and over again. If you want, to win an award, you just do something anyways, it's like this concept of just repeating something over and over again is how you make progress, right? To echo what you were saying, like a little bit, to respond. Yeah. And then, okay, cool. So I think I'll jump through this, and then yeah, let's get to the demos. I sped through part 1, part 2, part 3. Then we're gonna go to part 4. Alex, Patrick, get ready. Here we go. I'm wrapping up. Okay, so you know how I was like manually kind of tweaking the knobs on our neuron, right? In order to get our desired output, right? So does anybody know the algorithm? This is the next trivia question. Yeah, here we go. Yeah. Who said that? Who said that? Oh, yeah. Go. All right, so yeah. All right, we're almost done. Ginger, like we got some more toffee. Ginger, yeah. Oops, there we go. Nice catch. Yeah, so yeah, PyTorch will do, I guess mainly it'll do 2 things for you. It'll allow you to chain these neurons together at a huge scale. So you'll like let me show, this is a cool thing, right? This is the last visualization, and then, all right, this is the last visualization, and it's you guys, all right? Ready? Yeah. Here we go. Yeah. Right, you're like, okay, like this neuron, right? Like all it's able to do is right? Lo and behold, when you start, you put one neuron and then that output of the first neuron feeds into a second neuron, right? And then that feeds into a third neuron, feeds into a fourth. And then what you can also do is you can have one neuron, it feeds out, and then you can feed it out into 2 separate neurons. Or you can feed it out into 3 neurons, right? You can stack them. You can start chaining them in different combinations. So when you start doing this in different combinations, you start like having these systems that can do, you know, more advanced things. And like this is another level up of like, I guess you could say, sophistication of what a system would be capable of. But this is a model that tells you, given a certain temperature and a certain time that you're going to cook coffee, it's going to tell you if you're going to make a good cup of coffee or not, right? And an interesting thing, like when, I mean, you can analyze, like I said, I'm jumping ahead. I guess I should know at this point, I got to keep it super concise. But anyways, this is a neural network, right? So this is the visualization of 3 neurons, right? And here you can kind of you can start to get a feel of like each neuron is starting to learn a specific type of thing. For example, you can see this neuron starts to light up, right? When the combination of temperature and time starts to get above a certain threshold. This would be like, okay, like the neural network, right, is telling you whether you're going to, given a certain temperature, right, that's the input. For my input, it was, right, that's all the input for me as a neuron, right? That's the only input I was receiving. For this neural network, which is a combination of 3, it's receiving 2 inputs. It's receiving a certain temperature and a certain time, right? And it's going to say, if you were to cook some coffee for that amount of time, it's going to tell you whether you're going to cook a good cup of coffee or not, right? So the first neuron, you can say like this, what this neuron is getting good at doing, right? This one's getting good at telling you if you're too low on the temperature, right? So this is like, it's lighting up right here when the temperature is getting too low. This is like, okay, like this neuron's going to start to fire. It's like, okay, like you're getting, you know, the temperature is getting too low. It's not going to end up with a good cup of coffee. That's all he can do. He's like, I don't know anything else. I just know that's like too low temperature, right? Yeah, I guess. Yeah. The attention node goes, yeah, I mean, yeah. You want to expand on that? I guess I don't know exactly what you're saying. Yeah. Yeah. I mean, yeah, this stuff is pretty. And then, like, I guess it's cool. I guess I'm still learning more of this stuff, but you can, like I said, I'm learning more as I go. But you can say the second neuron, right? This, like, now we chained 3 neurons together, right? And we gave it the task of, given temperature and given, you know, a certain amount of time, tell me if I'm going to cook or, you know, make a good cup of coffee. This second neuron, you can see it's lighting up when the time is getting too low, right? So the second one is like, it's lighting up if the time is getting, it's like, I don't know anything else. I just know like this amount of time, it's not going to result in a good cup of coffee. I don't know anything else. That's all I know. And you can see this third one, he's getting really good at identifying if the combination of time and temperature is a good combo. He's like, I don't know what the temperature is. I don't know what the time is. I just know that this combination of temperature and time is good, right? So it's like, anyways, like I said, but just boiling it down to that fundamental unit, right? You would think this stuff is so complicated, right? Like this AI stuff, like I literally just gave you the key of all this shit. Now you can go out and build your own systems, right? It's really that simple. So yeah, what PyTorch is going to allow you to do is you can chain millions and billions of neurons together, right? You don't even have to think about it. And also this thing of tuning the knobs, you don't have to do that yourself. They have a function, back propagation, autograd, right? It'll do all that stuff for you. All you have to do is just provide it with data. You have to tell it, here's the input and here's the desired output I want. You just have to have a bunch of examples of that. And then the neural network will adjust itself to, you know, get better at the task for the given data that you're piping through the neural network. All right, so let's get to the demos. Alex Comerford, he's been doing this for a minute. He's a really talented engineer. I built a system, you know, about 2 years ago called Caligo. It was an open source, you know, project that I did. I had a lot of fun building, and he discovered a bunch of vulnerabilities. He scanned all my code, so he's really good at security. He has a wealth of knowledge in a bunch of different areas. But yeah, I mean, I'm excited, you know, to see what he has. And then yeah, let's see how this goes. Right, going with the flow. Yeah. All right, cool. So I guess
that did happen.
Yeah.
I found a bunch of stuff, but did you patch it? Hopefully.
yeah. We fixed some of it.
Yeah. Ooh, is there an adapter thing? Oh yeah, that's right here for this thing. Thank you. Absolutely.
Yeah.
Okay.
We'll talk soon. Yeah. Good to meet you.
Take that.
Like the swag.
Well, thank you so much, Tad. We'd like to go ahead and pull people from our community in order to help teach other people within our community at GPTuesday. So Tad has been an early member here and has been teaching different areas from vector search and now PyTorch Fundamentals. And so thank you again, Tad, everyone.
Thank you.
Now we're going to go ahead and bring up to the stage who's already here, Alex Comerford. Let me go ahead and help you with this real quick. I think we have to. Oh, there we go. There we go. So Alex is a senior machine learning engineer with experience from places like Bloomberg and Coinbase. He helped build the Bloomberg terminal, if that's right, for the financial side. Yeah, a little bit of work on that. So he's has deep experience with machine learning. And right now he's actually building large language models using PyTorch. So he has very deep experience with PyTorch. A little weird. No worries.
Oh man, I got a weird view. That's really. All right, we'll have to do it like this. Oh man, that's weird. Yeah, that's kind of a weird thing. That's okay. Yeah, it's a Linux thing, of course. Okay. Well, we might have to deal with that. I'll also work around it. All right, there's gonna be a little bar in there. Do I need this, by the way?
Oh yeah.
Yeah. So let me go ahead and put this.
Okay. I got it. Good?
Perfect.
All right.
Yeah,
Sounds
there
good.
you go. Cool.
Hey everybody, I'm Alex. Just out of curiosity, how many people heard of? I'm just polling the audience a little bit. How many people have heard of PyTorch before coming tonight? Okay, like maybe 3/4 of the audience. How many people have like programmed in PyTorch or did model development in PyTorch? Okay, cool. Let me think of a follow-up. How many people have heard of Hugging Face before, the company? How many people have like used their product and like downloaded models or used their inference endpoints? Okay, how about their data sets? Any data sets hosted on there? No? Okay, that's interesting. Okay, the demos that I was going to show tonight are taking Hugging Face models, downloading them locally, running them locally on some GPUs I've provisioned, and just showing what it's like, what downloading Hugging Face models and hosting them is pretty much like. So, speaking of what Tad and Grant were mentioning, Meta, as of today, I think like 5-6 hours ago now, dropped all their new models, the Llama 3.1 generation. It's supposed to be bigger and better. Haven't done so much. Oh no, that blows. Hold on, let me try and reload. Is the television or? Yeah, maybe I should just demo and just not just. Oh, on this side you can see it?
Oh.
Weird.
Yeah, that's bizarre. Maybe the TV is up. Okay, maybe that was the issue.
Let me try unplugging and replugging back in.
Could be that. Okay.
Yeah, live demos, Hopefully.
Just show HDMI somewhere, which I'm not seeing.
Don't know. Is it on?
Oh, there we go. Cool. Perfect. Thank you.
Connect that? Did it? Okay. Weird. So I will have to maybe pull this to the side here, and we'll do it like this. Okay. So for those that have not seen Hugging Face before, because I know it was not all the audience, this is effectively what Hugging Face looks like. I like to describe it as GitHub for AI models. So back in the day meaning 4 years ago, when trying to download models and use models, you have to pull stuff off of GitHub. So you'd have a repo that kind of looks like this. This is example, the YOLO generation models. They draw bounding boxes over specific objects. That's the whole point of this model. But you'd have to go into a model and figure out how it works and install the dependencies and do a bunch of legwork and engineering work in order to get it to work. However, with the advent of Hugging Face, it's made this entire process much, much easier. Where I can, let's say, example, Meta's 3.1, it's top of trending for obvious reasons, got released today. Literally, an organization can upload their model and a bunch of model code and a bunch of configs, which I can show right here, files and versions, looks very much like a GitHub repo. And with these configs, you can use Hugging Face's libraries, mainly their transformers library, to actually use this code. So they even have this little use this model thing, and they can do a little bit of code gen to show you all you have to do is just copy paste this code, and you can use these models. It's that easy. So it's a lot better than going to a GitHub repo and trying to install all these dependencies and figure stuff out. You still have to kind of do that with transformers, but once you have your environment, you don't have to figure out any more stuff, anything that's very custom to this repo. So the first demo I was going to show, hopefully I can pull it up. Give me a second. Get the right term thing right here. So since I thought it would be apt, I prepared something a little bit earlier today. I thought it would be apt to take the 405 billion parameter version of Llama and host it on 8 GPUs and ask some questions to it. So I thought that would be fun. And I discovered something pretty interesting actually just before I was sitting on the couch. I was testing this out. Maybe I'll show actually how you use it very quickly. It's a few lines of code. You just say what repo you want to download, and then you use an auto tokenizer specifically for for the language model classes, and also the auto model for causal LMs. You pass in just a model ID, do a little bit of boilerplate, and like magic, you have access to whatever model you want that satisfies these specific classes. And the cool thing I kind of found out was it seems like GPTuesday was actually in Meta's like training data set, because when I asked earlier today, meaning like 30 minutes ago, what is GPTuesday, or have you heard of GPTuesday? So that's a prompt right here. I'm going to, hopefully this will work. Paste in this little bit of code. And at the bottom here, have you heard of GPTuesday? And okay. So Llama 408 or 405 billion parameter. This is very slow, which is interesting because this is hosted on like 8 A100s with 8-bit quantization. So even with quantization and on very fast GPUs, it still is only getting a few tokens a second, which I think is interesting. Yeah?
What are the statistics? What is the GPU? How much GPU memory is there, and how do you plan ahead so that you know how much hardware you need to run these various models?
So it isn't like a one-to-one what you see in like a Hugging Face repo. You'll see like, okay, all the model weights are like, you'll see like 4 gigabytes times like 131 files. And that doesn't always map one-to-one to like exactly how much GPU memory there is. There's like buffers and additional space. Usually how I do it is I'll start off with I'll do the one-to-one comparison and then try and go over by like another like 5-10 gigs of like GPU memory. That's just to have a little bit of margin of error and margin of safety. So in this case, let me see actually. Yeah, so in this case, I think the total was like 386 gigabytes was like the whole model in here, but I'm using 8 A100s, which is 81 gigabytes of GPU memory times 8. I don't do public math, but it fits. A machine like that, it costed 8 times about $230 an hour, so that's 16, almost $20 an hour. Yeah, but that's for the 405 billion version. Like this is like only for the beefy big kahuna like models. I don't know. This has been generating for quite a while, but it's kind of cool. Like oh no, we can try and go up and try and read it. Where was it? I don't know if you guys were reading it. I didn't see what it. Did it recognize GPTuesday? Okay, it did. Okay, nice. Yeah.
So, I guess it's sure. So, of course, you don't have the GPUs there on your.
No. Yeah.
They're hosted on AWS.
Theoretically, yes, but I'm using a service called like Lambda. Yeah, Lambda GPUs. Yeah.
We're just wondering if you could ask like a factual question, right?
We can try.
I would ask either what city or
What city is?
Oh yeah, where is GPTuesday? No. That's very accurate. And what city is it hosted in? And who is the founder? So it's very possible I might get this wrong, but we'll see. Oh wow, that looks like garbage, but all right. No, I'm not aware of any founder. Information about a founder? Okay. So I got more demos than us just watching like a few tokens like stream. Okay, so this is probably a bad trajectory. I was going. It's possible that it's a local event or community. So maybe somewhere in it. Maybe if we do a few like chain of thought like prompts, we can try and piece it together. Anyway, yeah. So it's gonna ask for more info. Anyway, that was Llama. I'm gonna go to like a few other models. The reason why I wanted to do Llama first is yeah.
Does Llama have parameters like temperature?
Oh yeah.
Okay,
Well, that's actually like part of the transformers library to do different types of sampling and set temperature and like probability mass, how you want to set that. Yeah, that's literally what I configure up here. I just do temperature 0 because there's certain optimizations that I'm pretty sure transformers, the library does. Like you can do faster computation with temperature 0 than higher sampling, than sampling with temperature. Yeah. Anyway, I wanted to do this one first because loading up like hundreds of gigabytes into GPU memory takes like 10 minutes. So I kind of like preloaded that. The other things are like a little bit faster. So I'll now unload all of that and we'll do a different demo. So another thing is, let me see if I can. So yeah, downloading models is pretty straight easy. You can just copy the code and then do a little bit more boilerplate to actually use it. There's other models as well. So like finding a new model to download is as easy as just going to the search box and looking up like, oh, is Stable Diffusion here? And Stability AI, oh, look at that. Stable Diffusion medium. And it's easy as using it with the Hugging Face diffusers library, like this three lines of code. And you can see all the model weights are stored in like these few safe tensor files. Another safe tensors is also a format like made by Hugging Face. I'm pretty sure it's one of their libraries. And using it is as easy. So if you want to make your own little Mid-Journey clone, this is it. This is all you'd have to do is these three lines to download Stable Diffusion. You should have a GPU probably to run it fast. But I have a few prompts in here. One I generated earlier, just in case this doesn't work. I just want to show some images I generated earlier. Stable Diffusion 3 has the ability to imbue text in an image. So I said, have a sign that says, welcome to GPTuesday. If it wants to show. Ah, boo. Oh, there we go. Yeah, so this is like a few images generated by Stable Diffusion, following like the Mid-Journey style, like a 2x2. And all I have to do that is demo 1. While I run this, I'll do another like generation of a cute happy robot. How about this? We'll say like a cute happy robot holding a sign says, let's say GPTuesday is the best. That's a nice one. And I will run it down here. Do demo 1. So it'll take a minute to load up the model into GPU memory. While I do that, while that loads and runs, any other questions? Okay. Yeah.
So have you ever run a model on something that doesn't have a GPU?
Yeah, you can run it on CPU. Transformers will default to like CPU runtime, and also PyTorch underneath. Yeah, it takes a long time.
Really
Yeah.
slow, right?
Yeah, I don't know how to quantify how slow from CPU to GPU. You'd have to take benchmarks like yourself.
I think 50x on average.
Sure.
That's what I
Why not?
started reading.
It
The follow-up question was, which model did you use that was the
well, smaller model will be faster, less multiplies and less adds to do. Larger models will necessarily be. It's a very weird kind of game to quantify because throwing more GPUs at the problem doesn't always mean it's going to go faster, because there's also interconnect like communication, especially if you involve multiple machines. There's like latency between machines. There's a lot of different timing factors to take into account. One model on one GPU will be like, if it fits on one GPU, will be the fastest, because all data being transferred will fit into like the cache memory. So that would be like the fastest. But yeah. So, and luckily, Stable Diffusion 3 medium fits on one GPU. Not even a big one too.
non-GPU? What's a non-GPU model that you found was the fastest? That you personally experienced?
Personally, I mostly host stuff on GPUs, mostly, but you can run this on CPU. Just be prepared to like wait 30 minutes for that. So you can just run this code on your normal laptop. You can fit this into CPU memory. I think it's like.
What's that OCRing library from? I think it's IBM or something. It runs on
From IBM? Not too sure. Anyway, let's see what it generated.
Tesseract. That's all.
I thought the Tesseract was made by Google, but maybe not. Don't worry, we're going to do OCR. So we have some new generated stuff. Hopefully what did I say for it to do? To generate GPTuesday is the best? Yeah. The Michael Jordan one with blood on his face was Tad's idea.
I wanted to show how, with some of these other providers, when you're using a model through a company, sometimes they'll restrict the types of prompts that you can do, right? So I thought, like, okay, Michael Jordan, blood on his face, showing how competitive
There we go.
it is. That's like,
So yeah,
it's not so far left.
cute robot.
Right? So like, but yeah, when you run your own models, you kind of just have free reign to do whatever you want.
Yeah, this is a good point that Tad's making. Is like, what's the reason for actually hosting your own models? I only think there's really three. Is one, if you really care about having control over all different kinds of parameters. Two is around security and like privacy. If you want to like host stuff, host private data yourself. And I'm blanking on the third one. Oh yeah, I think it was like controlling cost. You have much more like fine-grained control of cost, I believe, over than an API. You control the infrastructure. You can control how much you want to scale out and scale down any particular model, opposed to having like something that's like marginal cost. Anyway, so that's a cute thing. Like all these little cartoon robots. The next demo is going to do better OCR than Tesseract. So there's another model called Quen, which I'll show. Again, it's on Hugging Face. You can get it yourself. Quen VL, it's called. This one. And Quen is a model made by Alibaba that's a multimodal LLM, so you can understand images as well as text. And it is banging at OCR, better than Tesseract by like a long shot. And like I can see with doing like chain of thought, you can get some like pretty banging results. I think even like don't quote me on this, but I think in their benchmarks they show that Quen VL or one of their bigger models like performed better than GPT-4 at document question answering. Anyway, so we're gonna run it.
How big are the Quen models?
They have a variety. They have a VL, VL plus, VL max, but Plus and Max, I believe, are closed source. Quen VL, let's take a look actually, because I don't know off the top of my head. At least just the raw tensor weights here are 10 files, each of 20 gigabytes. I think it was based off of an 8B model, and then also with the addition of like a clip image encoder, and I think an additional cross attention layer. But it looks like it's about 20 gigs, the whole thing.
They're like 1 megabyte.
Sure. Yeah, but depends what you care about in terms of like maybe you can just merge them both, and probably you might even get a better result by merging both. Anyway, let's go to Quen. So Quen, again, I'm using the same classes as before: Auto Tokenizer and Auto Model for Causal LM. You can just again copy paste this directly from the Use This Model button. And the thing I'm going to OCR is an image. I went on vacation and I spent a large time learning about interactive theorem proving. So this is just like a section from Lean, the theorem prover I was learning about algebraic structures. Anyway, so we're gonna OCR this image, and to OCR that, let me close all these and go to demo 2. We're just going to pass this image, and I'm just going to give it the instruction, can you please OCR this image? And if we do that, again, we have to spend a little bit of time loading the entire model onto the GPU. I'm pretty sure I can even we can see utilization. If I do NVIDIA SMI, this is a bunch of beefy A100s, and this is the one that's getting chosen. It looks like it's using over 1 gig so far. But anyway, oh no. Okay, wrong image. I think it's under data. Okay, I spell that right? Oh, did I? Oh no. I think I accidentally. Give me 1 second. I hit suspend. Boo. Might have just turned my laptop off by accident. That sucks. Any questions about Quen? In the meantime, hold on.
When you do the share screen,
Yeah.
share the whole screen potentially, because I think it's
Okay.
only sharing like window.
Oh, I see.
So you know.
I will do whole screen. Please detecting device.
Get a question about Quen.
I had a question about training your own models. Like in your everyday workflow, if you're hacking on something, are you training your own PyTorch models, or are you going on Hugging Face and finding the model?
Mostly going on Hugging Face. That's something that's like pre-trained. Like making these new foundational models is extremely difficult and takes a lot of money and time. You have to have a budget. And
what about for like simple things?
There we go.
Like, I remember you used to just have a sentiment model.
There we
all
go.
it did was the float value from 0 to 1 on how happy.
Sure, yeah, you can train a model like that, but if you have the time and data and you're willing to like invest the money, depends if it solves your task. That's like the biggest thing.
Most of the time you find one to solve
yeah. But mostly I'll find one on Hugging Face or somewhere else that can like solve my task. Let me. Where were we? Instead of let's not click the wrong button this time. Anyway, so I tell it to OCR this image. We'll get a response down here. And let's compare a little bit of what Quen says versus like others. Well, imagine that bar, but mathematically a ring consists of a collection of objects R, operations plus an X. So that's nice. It kind of gets the whole thing. It doesn't get this little arrow key because it probably doesn't have that in its vocabulary, I would bet, or it doesn't like interpret that correctly. But as an OCR library, I think this is like outstanding. Now, Tesseract would probably do like of a similar performance, but the fact that like an open source free language model that you can download can get this type of quality, and you can talk with it and do chain of thought and additional tasks is like, I think, astounding. And yeah, that was the last one. I have one more demo, but I can like hold on that one. There's another language model demo. CJK? Yes, Quen does work with, yes, I think all those languages. I know it's definitely part of its training data set was Mandarin annotated images, like hundreds and hundreds of millions of them, even more. Yeah?
Yeah, so I guess it's two questions. I guess my biggest question is, what's the use case for PyTorch when you're, let's say, building a customer service app, like an AI interfacing engineer, right? You just build a full stack app and maybe you use LangChain, hook it up to like the,
Sure.
GPT API, or maybe you build your own AI tool. Why would you use PyTorch? Like realistically, when would it be worth the new model? Or
You can be hosting and doing inference on like a model that you download like on Hugging Face. Like under the hood, Quen, we can go to the source code of like how like Quen's actual like code that's running the model code, and it's using like PyTorch code underneath. So if you want to use one of these open source models, you'd be using PyTorch, or you'd be inadvertently using PyTorch probably by using one of the APIs of the big AI companies.
I guess my question is like, what's the use case for like
using? Yeah, like I was like mentioning before, for control over a model, you can control all the parameters, and all the data can stay with you. That's something your customers might care about, or you as an organization might care about. And also controlling costs. You have much more fine-grained control over costs. You're not like vendor locked into like one particular company.
I'll also say, like, I'll add to that, but like, especially in the realm of language, like the likelihood that you as like an individual can develop something that like hasn't already been developed by one of like the hundreds of companies that are like working in language specifically that you can easily find on Hugging Face, like very low. But when you're working with data, for instance, like any other kind of data, whether it's images or graphic data is like a big one, or scientific data, like there's a lot more opportunity to use PyTorch because there's probably not like there are gaps where companies haven't like developed things for different use cases.
What are you trying to optimize? I would
So
say.
when they give you a trained model, you can optimize it in several different forms for its abilities.
Yeah, you can you can continue to like run the training process, either fine tuning, full fine tuning.
Data,
What?
you can add more data.
Yeah.
Fine-tune,
Yeah.
fine-tune and optimize.
Yeah. There's like a few like empirical results that people have shown that like fine tuning using like LoRa's, though you won't be able to, or it's very difficult to imbue new information into the models. With LoRa, you sort of show them how to be more accurate at a specific task of things they already know, like generating SQL queries or generating code.
With more data, when you're
You can't make it learn new things. You can make it like be better at something that it already knows. Does that make sense?
Can you augment, can you fine-tune it on more data first and then run the quantization of LoRa on it afterwards?
Yeah, that I can see that. Like you run like full fine tuning on just more data, so you're doing like full parameter like fine tuning, and then do LoRa on some specific task. Yeah, then you can imbue new information and then like make it better at some specific task. Sure. Why not?
Yeah. No, so Patrick, is Patrick still here? Yeah, so Patrick.
Oh yeah, we can lean into Patrick's now. Patrick
No,
demo.
You have another demo?
I have one last demo. I was just gonna show.
Let's hop over to Patrick and then
Yeah.
the presentation's over. He did some amazing like little experiment.
Yeah. This will be the last demo I'm gonna show. Is there are other LLMs that exist out there. One that I also downloaded is a language model called Phi. Yeah, it stands for. Oh my God, that's a long conversation. But LoRa is low rank adaptation, I think is what it stands for. But all you're doing is taking an existing weights matrix and adding a low rank decomposition of a diff on the specific weights. I can get into more about what exactly that means, but that'll take a lot of time.
I always simplify. It's like you can there's weights all across the model, right? Where you can pull knobs that you can choose across the model. To update all the weights on a huge model like this, it's extremely expensive. Extremely expensive. So there's techniques where you, for example, will just update the weights on the last layer of the neural network, right? That's one technique. That's not exactly, I think, what LoRa
That's not LoRa.
Yeah, but that's an analogy of what it's doing. Instead of updating the weights all across the model, you're just updating the weights in a very specific part about it, and it's a subset of the overall weights, and it's much cheaper. And you can't do, you can't imbue, as he was saying, lots of new information into the system, but you can fine tune some aspects of what it's already good at, right?
Yeah,
like
exactly.
He was kind of explaining. So that's like LoRa. So
Anyway.
to tune a model is extremely expensive. And that's what Patrick did, did some experiments. So I have some numbers to show after this demo. Sorry.
Sure. No worries. The last demo I was just going to show, be very quick. In the Llama 2 generation, only had a context window of about 4,000 tokens. Could not fit very much. But now with new fine-tuned models that can support up to like 128,000 context window, you can like fit part of books. And so in this demo, I was putting in one of my favorite short stories. It's a casino odyssey in cyberspace. You should absolutely read it. And you can ask Phi 3, but without the book, saying what is the book? Tell me the main message and takeaway. Has no idea, but now I can paste the whole thing and give me the main lesson. And the main lesson, don't have to spoil it, but the main currency in the cyberspace is backed by human misery. You should read this short story. It's really good. Anyway, that's kind of all the demos that I kind of got. The code is open source on my GitHub if you do want to check it out. My GitHub is CMRFRD, and it's HF demos. Or just talk to me after if you want the code as well. Anyway, thank you. Now we'll bring Patrick up as well next.
$1,000 about one of the GeForce line. So NVIDIA has different lines that they use that they sell. I was showing photos of some of the models that they sell to companies like big tech companies like, for example, OpenAI, Google. These machines, those machines that they sell to the big tech companies, those would like cost probably like $20,000, $30,000, $40,000 each. NVIDIA has another line, it's their consumer line that they brand. I don't know if they still run with this brand, but they ran with the brand name GeForce for a while. The GeForce chips, they primarily marketed those chips to people who play games. Who want really like fast, responsiveness to graphics in their games, like that. But it turns out that you can also use those chips for training AI models.
Yeah.
And it wasn't planned by NVIDIA at all. And it ended up, like I said, it's made them one of the most valuable companies in the world. But anyways, he bought RTX, was it 3090? You paid $1,000 for it. And what you did was download Llama 2. I think it was 30B or 7.
It was a 7B.
So he downloaded Llama 7 billion. So the latest Llama that was dropped today, I think, has 405 billion parameters. So back to that analogy with the knobs. When you say parameters, that's how many knobs there are on the model, right? How many things you can adjust. So on a consumer line of an NVIDIA GPU that you could purchase yourself, like the max model that you could fit on that was one with what, like 7 billion?
It could be 7 to 13 depending on the method,
Yeah.
and sometimes you can get it as high as like 60 billion parameters.
Yeah,
But you have to be very creative, and then it's slow, So
obviously. So so I thought that was interesting. And then what he did was he fine-tuned Llama 2 to answer some Portuguese questions or something like this. So Llama 2 is not so good at speaking Portuguese. So what he did is he just typed in, here's an example, here's a question in Portuguese, here's how I want you to answer. Here's a question how I want to answer. Here's a question how I want to answer. So he piped in 1,000 Portuguese question and answers.
So, well, I could explain a little different. It's called the Guanaco data set, and it's like a data set with, it's like a data set with instructions and questions and answers in many languages.
Here you go.
Oh, thank you.
Yeah, that one's more for the live stream.
Sure. So I basically fine-tuned the Llama 2 7B model on a subset of what's called the Guanaco data set. And that contains a lot of questions and answers and instructions for many different languages: Spanish, Portuguese, French, German, Vietnamese, Czech, Chinese, Japanese, etc. So I'm going to give you like a high-level overview of how you could do this locally on your own desktop computer. So first, we're on an Ubuntu system, and I found that Linux works the best for this. And I basically create something called a Python virtual environment, and then I run a Jupyter Lab server inside that Python virtual environment. And it goes really fast just to try to fit the time, but then I connect Google Colab once a server starts with that URL with the token, so I can access Google Colab. And then now, as you can see, I'm doing pip install Torch, so like PyTorch, Torch Vision, Torch Audio. Then there are a few other libraries, Bits and Bytes, Accelerate, TRL. And I forked this from a tutorial on how to do it on Google Colab made by a guy named Maxime Lebon. But I was able to get it running on my RTX 3090. So basically, the biggest thing I'm going to tell you is that you have to watch out for library mismatch. Like, the harder part is kind of getting the environment set up, and that's why people use the cloud. That's why people use Docker and things like that. But if you play around with the libraries like Bits and Bytes and TRL and Accelerate and Transformers, you can get it working. This is a very fast demo to just show you, but it's 6 times speed, and this is me training on those 1,000 examples for fine-tuning the Llama 2 7B model. Is it worth it to buy your own RTX 3090 or another GPU like that? I think that if you're going to work, if you have the money and you're going to work in like AI for like next 2 to 3 years, it'd be very practical to help you locally like iterate and kind of learn machine learning and data science. And of course, for larger projects, you can use the cloud. But you can also use a GPU for other things like stable diffusion image generation, Autodesk Maya and Unreal Engine if you're into like modeling and video game creation, that sort of thing.
Mining crypto.
Sure. So
video games.
so you can see it's a personal choice, but I think I'm definitely satisfied with purchasing it. And now that we finished the training, we use this code here to combine the LoRa weights, the Q LoRa weights we ran to combine it to make it 7B again as a fine-tuned model. And yeah, so then I'm showing you right here, we're using something called llama.cpp. We're using 8-bit quantization. And quantization makes the model smaller, slightly like less intelligent, right? But it makes it easier to run, cheaper, less memory footprint, those sorts of things. And then this is just me going really fast through that, but that's optional because I was able to run transformers, which is the basic way of running like a large language model locally, right? So then, yeah, that's just how you would quantize it into a GGUF file format. And here I'm downloading something called the TextGen Web UI, which is a lot easier to use if you want to chat locally with a model you just trained. And if I go a little bit more ahead, I have it set up. I have a local server for this as well. And then now I'm just showing you real quick. I'm asking you the question in Portuguese, like the full software development lifecycle for a financial institution. I want it translated for a Brazilian client. And yeah, so in a moment, I started and now it's translating into Portuguese. And then we can see here, I go just a little bit more ahead. We can see I got 33 tokens per second average. It's really good. And yeah, you could use any model locally in this fashion. And if you want to find out more, you can look at the Hugging Face where I store the model. And you look at the Colab where you can run the same Jupyter notebook. So I hope you learned something today about how you could practically use this to fine tune for tasks like language translation or coding or other specific use cases that could help you out in your occupations. Thank you.
That's it. That's all, folks. Thank you. No, he did. Oh,
Thank you. Sorry about that.
Great, amazing.
That's the thing, like, it goes over people's heads, right? So he paid $1,000. No, not that big. Oh.
Amazing. Well, thank you, everyone, so much. Really appreciate all of you coming out here tonight where we are learning from one another. Here at GPTuesday, this is what we do. We help bring people from the community to help teach one another so that we can all stay ahead. So I would like to thank Tad, Patrick Devani, and of course, Alex Comerford as well for the wonderful presentation and for all the demos today. Thank you very much. If possible, please go ahead and share everything you've seen tonight on Instagram, Twitter, LinkedIn, and go ahead and post GP Tuesday. We would really appreciate that. Next week we're hosting. Next week we're having Micah Berkeley. He was a former machine learning engineer at BMW, as well as a Google Cloud architect as well, working at Google and BMW in the past, as well as Fashion Nova, also working on their generative on their machine learning side as well. So he's going to be talking mostly about, how can we actually utilize AI from a practical use case, right? How do we make money with artificial intelligence? How can we leverage, let's say, Hugging Face models, replicate models, whether you're a developer or whether you're on a less technical background. So I think that's going to be a very interesting one as well. So yeah, thank you again very much. And I would like to also do a little announcement with Prov. We're going to be you'll be hosting.
Yeah, it's the Strong AI Summit. It's October 10th at the Knight Center, a walking distance to Hyatt. Hyatt. Yeah.
Mm-hmm.
So
yes,
you guys have been gracious enough to partner on that. So you guys have a good opportunity to basically showcase your AI projects or your hobbies to the world. We're having the CEO of Rome, the $1 trillion city that Saudi Arabia is building. CEOs coming, we have a lot of other CEOs. So basically, every company that the Saudi Arabian government fund is investing in, we magically Lucid will be there. They've invested in some of Patrick's and local Miami video gaming companies got investments from there. So it's a good opportunity. So I think Grant's going to be sending out a sign-up sheet. So we already got like some of the keynotes already scheduled, but we'll have breakout sessions to highlight the Miami community. And then CES in Vegas. So you could definitely try something out here and make something more elaborate. So definitely it would be awesome if you actually have some ideas, maybe a community-run event as well. So it doesn't have to be like hardcore AI. I'm thinking like I'm going to be hosting the autonomous aviation panels.
Mhm.
But if you're into like smart cities or gaming, obviously, anything, just have a little bit of AI. So it's on topic, but I don't want to curtail your creativity. So.
Amazing. Thank you so much for helping us with that partnership. I mean, it's going to be incredible. We'll be bringing our community, people that are wanting to get in front of some of the largest investors in the world, and just talk about AI, the way you're using it. And we're going to be bringing some of the best projects that we have here at GPTuesday to the event. So we're really looking forward to working together on the Strong AI Summit. So thank you again. And after this, I'll go ahead and just share the Telegram community channel so that everyone can stay involved with our weekly events. And besides that, let's just get to know each other and have some great conversations. Thank you. Hi, Yara, how are you doing?
Good.
Good.
That's great.
Yeah, thank you.
Yeah, they all got lost on the way, but yeah, Kat.
Your GPU. If people take selfies with your GPU. Yeah. It's a
It's always good to keep yourself so that you set yourself up for the next thing. Learning how the brain works.
You did a video. Okay. Sorry, you were like, something like that. Captain Dick. Sorry. Yeah, just fighting evil allies. I remember this. Yeah, that's where I remember. I only remember when you come with the. Yeah, tangentially related. Right now. Okay. Yeah. There's
training models to map these thoughts to action. It's always the environment, right? They drill
This was more of like a show. Kind of like recommendation. A few other varieties. Or like, yeah, I don't know. I have you on top. Okay. Yeah, and fraud used
I know, yeah.
They're very slow. Morocco, yeah.
For me, like, this is good to understand, right? It's just like, instead of you having to go to the page, you understand where you got where you're
Surprised you have really Amazon has a lot of well, Amazon is a use case is a like so you we don't have they want you to spin okay. Okay. Okay, then yeah, that's probably that's for hours and that's more.
I did say
they had a different, I see what you're saying.
There are like
So like when you do styles, right? When you boil it down, it's really just like a simple application. You're just like graphics, you know, that's awesome. All the chip is just drawing.
you're saying it's I've done it now like disable the bad parts. So like after 20 times, it becomes like easy to know all the missing parts and like that. But like I've learned to just use the AMI, just use the goddamn deep learning AMI.
Right.
It's very interesting. Like trying to short I know that like we like it's like model service and on the back end, but you can ask questions which show you how to build. And it's I think Amazon that's why it's the same model. It's yeah, there's some AI behind it might be. I may not exactly. Well, because beyond VMs with GPUs, we're finding what else do you use in storage? What else do you really need? You're trying to sell like. We gotta add. Well, what if we added more bells and whistles, and they were really hard to use? That's like and like 20 demands. So that's the challenge. But we're trying to be on AWS plus because like of their. But I feel like they have like so they need to do compliance standards. It's not compliant. That's I mean AWS. Honestly, I don't think it'll ever get there. I think it'll be secondary or tertiary companies that are just resellers that gives a good experience, and everyone can just be there and exactly just be reliable in providing
Doing the work I did on the work process.
formatting it right. Were you in C#? Were you like Obama? There have to be like libraries for C#.
And also, identity, the number of pages, that gets uploaded, and then a Python program, which ChatGPT wrote, originally wrote it in C,
especially when doing like web requests in C. It's like,
so I got stuck there. Right, quickly got GPT to rewrite Python. So Python takes it, works the JSON structure, except for Llama. In JSON, it says the engine to make sure this first word never responds yes or no. So it's this Are you? It's not. But you are an engineer with yes or no. That's not just why. Yeah.
Oh, that is. Oh, you have a chain of thought. Are you studying this? So are you not people like it?
Every other company
How do you like it?
Yeah.
This is
the amount of like
So you did it like 4 years.
That's actually a good idea for economics.
Yeah, yeah.
Then I had to go through like learning how prompts what work and like
So
absolutely at this world.
you don't think it's
Almost and like 79 cents an hour. Token. Yeah, exactly.
I think you have to my model probably
T4 is I think 32. Yeah. You could have been on Model 3 72. That's one model that's 78 on you can get they sell the 4-bit precision. If you wanted to, chip is only like 4 OEMs that are running this size, and that is like what NVIDIA makes. But it's only if it's smart. I don't know, like it was just like making a bigger model. Bigger model doesn't always
they sell they're basically computers that are just for right now. That's like the first
like maybe refinement, I guess.
We had a Corolla, like a Corolla price.
Well, it's a growing
oh yeah, like a data center, three-phase, it's like so general. Like when I look at the power drawings,
Yeah, well, it's mostly like for this. It's like the largest.
you know, and they're running it like
The possible stuff is manufacturing sales. And there's like a preset.
check good transcript from how actually happened, and then charging them appropriately is like here's microphone everywhere.